put in a vacuum chamber and heated, it would have burned. Those are actually easier to deal with. The failure of this inference for counterfactuals is easier to deal with than this. But it works under the right assumptions here. If there's a way of doing this. This is sometimes called strengthening of the antecedent. This inference pattern. There are others that are also no longer valid. Things like this: if A then B, in classical logic it entails if not B, then not A. I don't have a counterexample to this on the handout, but if we can talk about this afterwards. There are sentences that clearly violate this inference pattern, and you can check for yourself that it, may well be violated if you have this kind of system. That is, the inference pattern is no longer predicted to be valid, which is good because it isn't valid in natural language. Because this connective here is a bad match for our natural language conditional. But this kind of thing here, this operation on modal basis and so on, is a better match. There are other inference patterns of this kind, which, well, some of which we have on the handout, where from not A it follows that if A then B, and from not A it also follows that if A then not B, should we go through this a little bit more, or are you satisfied? I mean, we can perhaps, let me not do that now, actually. We only have 10 minutes left. But we can, if you ask in the next hour, we can look at some more cases where ordering sources help you to to break these entailments, right? Okay. Now this is for what she calls and what's generally called indicative conditionals, the ones that we saw here, if this is heated and so on. Now there is this other class of conditionals called counterfactuals. We still have 10 minutes, so I'm wondering. I mean, this is the last thing before we get into this other topic of these other readings. Now let me try and say as much as I can about this. Okay, here for these, the rule you have in 14 now is spelling out the truth conditions of the conditional, right? So if alpha must beta, and we have must in here. We didn't see must in the sentences, in the example sentences. The assumption here is that you have a necessity modal in there even if you don't hear it. Okay? So if this material is heated to 500 degrees, it will burn. Oh, you have a will, in fact. There you actually have a will, which is a bit like must. So you have a modal even. But sometimes you don't. Right? If she is at home, she is happy. Even there, the assumption is that you have a modal operator in there that is silent. You don't have an overt auxiliary. She is necessarily happy or whatever, she will be happy. But still, conditional is a modal expression inherently. That's why you can put this here. So now there I put this condition there the way she writes it with these brackets here. So far I didn't do that. I said V of such and such, right? Now I wonder which way should I go? Let's do it like this. Okay. W if alpha must beta. But now earlier we had v of w, and then we had this index, right, that identified what modal base we're dealing with. Likewise here, somewhere we have to indicate that we are talking about f, and I'm running out of space, but let's just say we have a list here that tells you what world we are at, what's the modal base, and what is the ordering source. Both of these parameters now determine the truth value of the conditional jointly with the other facts in the model. And this is true if and only if, well, in 12 you have it all written out, but if you look at 12 closely, you'll see that this is just another way of writing the definition for for human necessity. For every world W prime, there is a world such that, oh, there's actually a typo here. So let's not even go through this. Sorry, that's a typo. Let's jump right down to 14, okay? Where this is translated directly into where the statement here is translated directly into this possibility that this necessity modal must beta. So alpha has gone away, right? Where has alpha gone? It is now in here, and it has been added to the modal base, because that was the operation that was involved in this, all of this, right? What restricted the modal base from this big white circle to the pink circle, that was the addition of the antecedent over here, right? This union thing. So let's write this as plus A. If you read Kratzer, she just says plus, and then you have to somehow say somewhere else where A is coming from. This is now the way these conditionals are interpreted. You see that somehow in there is the assumption that the antecedent modifies the consequent. This, if alpha, right, this affects the way beta is interpreted, but actually the sentence is really just a modal, a necessity claim, necessity statement like this, must beta, and by the way, not must beta with respect to the whole modal base, but only with regard to the A worlds in the modal base. That's what the conditional amounts to now, right? An assertion of the consequent relative to a different modal base from the one that you start out with. And now if you write this out, you see we had this up here just before, right? Now this is true if and only if for all, now I'll try to write it correctly because 12 is not right. For all W prime in this now, F plus A, right? Of W. There is a, I need a different variable already. I have the same W prime again. I need this, of course, because it's a different world, right? There's a W double prime also in this modified modal base. And just to make this clear, that's the same as saying this. It's just a different notation for this, right? So this is in fact also F plus A of W. So there's that, such that W double prime is at least as good as W prime relative to the ordering source, and for all, now we need a third variable, right? for all worlds in, again, the same thing, f plus a w if, now we'll just say, if w triple prime is at least as good as w double prime, right, then beta is true. So we can say b w f plus a g of beta is 1. So I'm sort of mixing these things, but this is what I just wrote. This is what the conditional now means. If we don't have an ordering source, it again, as before, it comes down to subset relation. If we have an ordering source that picks out different ideal worlds here in different cases, then this becomes more interesting, right? Somewhat weaker claim. Now I do want to say something on counterfactuals, but we are at 3 o'clock and we have to take a 15-minute break. So the last hour we'll spend on this one remaining page of this section, and then we'll say some things about the next sections. We don't have much time to spend on this anyway, because, or we don't have to spend much time on this anyway, because it's short and somewhat inconclusive and more preparatory for tomorrow. So I'd say let's just be back here at 3:15. And if you have any questions about this, think about them, ask them at the beginning, okay? Thanks. If not, I will just briefly say something about counterfactual conditionals. The basic rule for counterfactual conditionals is the same. Let me give you an example so you see the difference, because in Japanese the morphological distinction is not so clear. In English it's much clearer. So you have, as I said, you remember these sentences. If this material is placed in so if this material had been heated to 500 degrees, it would have burned. And then we also have the parallel sentence, if this material had been heated to 500 degrees and, sorry, again, place in the order of these things matters actually, because otherwise you think the temporal order would be different. So I have to write it out. Okay, if this material had been placed in a vacuum chamber and heated to 500 degrees, it would have burned. And the burned. Again, so we have replaced this with this, and would here we have replaced if this material is heated with if this material had been heated, right? And likewise, it will burn with it would have burned. And the implication now is, it's not an entailment, strictly speaking, but it's strongly suggested by conditionals like this, that the material, in fact, was not heated to 500 degrees, and that it didn't burn for that reason. It may still be there, but you may still believe the conditional. If that's the case, then we can't really do it in exactly the same way as here, because, well, see, you use this counterfactual when it is, in fact, counter to fact, when it's a real counterfactual. That is, you believe that the material was not heated. Okay? But then you cannot, so your modal base in particular, your modal base consists of worlds where the material was not heated to 500 degrees. Then you cannot add the antecedent to it consistently, right? Because, you know, if this is your modal base now, and you believe that the material was not heated, then the proposition that the material was heated is disjoint from this thing, right? There are no worlds in your modal base. They are all somewhere here, whatever. So this is A now in our case here, right? And adding A to F will put you in a bad position because you end up with an empty intersection, right? See why that is. Okay. So for this kind of conditional, Kratzer suggests a somewhat different approach. Although it's again with regard to ordering sources and modal bases, just like before, but they are actually a different kind of modal base and ordering source. The modal base before, we said, was most likely your beliefs or something like that, right? An epistemic modal base, something like that, or circumstantial, some of the relevant facts. But it was one which contained lots of worlds, right? Which did not uniquely specify some particular world. We said that W of the world of evaluation may in fact be in here, but of course it doesn't have to be the only one. And it shouldn't be, because if it is the only one, then, as you can check for yourself, all of this makes the conditional equivalent to the material conditional if the modal base contains only this one world of evaluation. Okay. So it has to be a large set of worlds, and it has to be compatible with the antecedent and so on. That was for the old conditional we saw an hour ago. The indicative conditional. Now here the idea is that what she says here, I have it on the handout, I hope. At the top of page 11, a counterfactual is characterized by an empty modal base and a totally realistic ordering source. Okay, what does that mean? I have to get rid of some of this chalk here, sorry. Well, I'm trying to conform. So we have the set of all worlds here, W, and now an empty empty modal base means we have the little w here. F of W is the empty set of propositions. And now what is the intersection of that? The set of those worlds which are in all the propositions in the empty set of propositions. That is the set of all worlds. Because it's again universal quantification over an empty set. There are no propositions, so every world is a member of all the propositions in the empty set, right? So the modal base is now all possible worlds. There are no restrictions. And immediately you see that you need something more, because if you do that, then you end up again with an entailment from this sentence to this sentence, right? So the antecedent now, we know that it's false, or let's suppose it is actually false. Not only do you think so, it is in fact false. It will be somewhere maybe over here, right? This is A. But then remember we had A and A prime, and this conjunction here is really the intersection of A and A prime, and if A prime is this set, then for the second sentence we have this. Okay. Now without an ordering source, we would again run into this problem. The first conditional can only be true if A is a subset of B, right? It has to be B has to be something like this. Well, yellow, alias yellow. Yeah. Maybe something like this, I don't know, right? Then this is required for the first conditional to be true. But if that's the case, then this is also a subset of B. So the second conditional cannot be false, unless here you're also talking about then perhaps vacuous quantification, but in natural language we don't do quantification over empty sets, so that would be bad for a different reason. So the entailment is predicted to go through, and again an ordering source is Kratzer's way of getting rid of that problem. So let's see. So we want to say that in fact the first conditional is true and the second one is false. So in fact B doesn't look like this, but rather like yellow. Something like this. Okay. I don't know. I mean, this is just, you know, something like this. And now, so we have the empty modal base, and the second parameter is a totally realistic ordering source. Totally realistic. And that is defined earlier in the paper. Realistic means the world is in the ordering source. Sorry, the world is in the intersection, right? Remember that from reflexivity, so on. Totally realistic means that the world is the only one in there. So the ordering source, G of W, when applied to W, identifies the singleton set containing just the world. The intersection of the. The intersection of this identifies one world, right? A singleton set containing just one world. That's what it means. That is the definition of totally realistic. But of course, G of W is not this thing. G of W is a set of propositions. Some set of propositions. It can be anything as long as the intersection contains only W. So you can have perhaps these circles like, you know, like this. All of these guys are, well, I want to be some circles go around here, right? I don't know, so, well, here. You get the idea, right? The intersection has to be just this. And there can be 2 or 3 or many or infinitely many propositions in there. And now here we have, again, ensured already, I have ensured by the way I drew this picture, that the first sentence is true and the second one is false. Because now with this ordering source, we are, the first conditional now, we are looking only at these guys here, right? along the here, the ones that are actually members of one or more of these sets in the propositions in the ordering source. And the words down here, they don't count because they make no proposition true that is in the ordering source. Ones up here do. I should say writing it in this spatial way is good for the eyes, but it could of course be that you have a proposition here that is sort of disjoint or goes around here or whatever, but never mind. So the first conditional is true under this assumption. Well, because these A words here, they're all B words. The second conditional is false because the A and A prime words are down here, and B is false down here. Right? B is true up here and false down here. Okay. So again, this is how it's done with counterfactuals. Now this is perhaps just one reading, of course, for the counterfactual. A totally realistic ordering source gives you a reading which basically says, what would be the case, not what would be required, because then we would have a deontic reading and so on. We'll get to that in a second, next. But for now, you see that this is pretty much the same picture. What differs is just, the role of the modal base in all of this, and the way the ordering source works in ranking worlds. But the rule is the same as this, no difference. All right. And then she also points out that there are many ways, many sets of propositions that uniquely identify this W. And you can play with that and see that depending on which set of propositions you choose, you make different counterfactuals true. But we shouldn't go into that. That's a whole topic in itself.
B がその A と A プライムのインターセクションに絶対かからないと保証はどうやって
保証はないですね。こうだったら A と A プライムなら B が E になる。こうじゃなければ E にならない。Okay. Any questions now? Yes. Hi.
ロジカルクエスチョンですけど、トータリーリアリスティックっていうのもフレームの観点からコンディションが与えられてて、モーダルフォーミュラとコレスポンデンスがついてます。で、今ベースが違いますよね。ファンクションの F っていうのを導入してその心理条件を与えてますけど、その時にもトータリーリアリスティックっていう条件はシングルトになるっていう条件でかけて、それと要するに意味論の枠組みが変わってるけれども、コレスポンデンスの関係っていうのは変わらずに成り立ちますかっていうのが質問。
成り立ちますよ。その totally realistic, right? So a totally realistic conversational background, modal base or ordering source, they are both conversational backgrounds, right? In terms of accessibility relations, they correspond to the identity relation. Is that your question or not? Was that your question? Which relation it is? Is that the answer to your question?
聞きたいのは
ごめんなさい。
モーダルロジックではそのアクセシビリティリレーションのトランジティビティがこれとか、これがこれっていう関係が成り立つのはよく知られてるんですけど、こういうふうにフォーミュレーションを変えたときにもこれがこれに対する、これがこれに対応するっていうのは
Totally realistic の場合、どうかですか？
トランジティビティの場合とか他の場合にも言えるんですか？
他の場合にも言える。
例えばさっき心理条件を書いていただきましたけど、ボックス P ならばボックス P っていうのが書き換えた場合にも、
その中でこれがこれを使ってたよね。これが reflexivity だったよね。ですね。はい。これが totally real. これが realistic conversation background. これは totally realistic になります。ちょっと考えればわかると思いますけど、今なんかいいですか？わかりますか？ちょっとまあ、OK ちょっとこれを消してもいいですか？OK, I can already. So a realistic, remember, realistic conversational background is corresponded to reflexive, I want to put it here, a reflexive ordering accessibility relation, right? And there the axiom was this. Right? Because I mean you can think about why this axiom gives you this. We didn't prove that, right? We used the other one for serial to go through this little proof. We can go through this if you don't believe this, but it is characterized as the reflexive frames. On a reflexive frame, this is valid. On one that is not reflexive, it's not valid. So, just to see this, on a frame that is not reflexive, there has to be some world, perhaps this, which doesn't have a loop, right? The others may have one, but there's one that doesn't have a loop. Now, if you say not P here, and if it has no outgoing arrow already, it's a counterexample, because box P is true and P is false. If you have outgoing arrows, then you simply consider a truth value assignment where you have PP. Then again, box P is true, P is false. Right? This could not happen if you had an arrow around it, because if then P is false here, then box P couldn't be true. Right? And then there's a proof in the other direction. So, right. Here the condition was that W is an element of RW, of the modal base. But RW may contain other things. Right?
すみません、RW にするんでなくて、インターセクションの F の W にしてもと話が通りますかっていう質問なんですけど。
はい。あ、それは、はいはい。
それだったら。
それだけですか？
それだけです、それだけ。
ありがとう。じゃあ他はこれがもう明らかですか？
トータルリアリスティック。
はい。So, well, yeah, so let's see. If we have totally realistic, we have W is a member of this, right? And nothing else. So, well, let me just say W equals the set containing just W equals that, right? But there are really two conditions. First of all, W has to be a member, which that means it has to be reflexive. And then what's the other one? Okay, that may be a little bit more, a bit less clear. Can I erase this picture here? Is it okay? So perhaps it's useful to look at a frame that is realistic but not totally realistic. That is, for example, the case if we have this. So it is reflexive, and then we have arrows like this. So just one arrow should be enough. With the arrow, it is not totally realistic. Without the arrow, it would be. Now we want to say that this axiom, right, which is this direction here, that this ensures that the arrow is not there, right? because what I have here is the conjunction of these two things. The upper one makes sure that there are loops everywhere. The lower one is supposed to make sure that there are no other arrows. There are only loops. We want that because right now, if this is W and this is W prime, then in the modal base at W we have two possible worlds, right? We don't want that. So let's see, can we find a truth assignment on this frame that makes this false? So that is, I'm currently exploring the claim if f wait a minute, can we, no wait, wait a second, so let me write this down somewhat more clearly. So the claim is f is, well, let's say an identity frame, right? An identity frame where the relation is this identity relation, okay? F is identity if and only if this holds. And let's stick with this. So again, we have these two directions here. We can prove them in different ways, so one by one. So first of all, to go from left to right, suppose F is an identity frame, which is what we have right now, and this axiom is not valid. If only if this is valid, right? Is not valid. Okay, what does it mean for this to be invalid? Okay, so let's see. That means there is some V, right, and some world. There is a V. I don't know how to stand here. I want this to. There is a V, and there is also a W, such that V of W at W of this conditional is false. Now the biconditional says that V, so whenever you have something like this, phi if and only if psi is 1, if and only if V of phi equals V of psi. Either they are both 1 or both 0, right? Now this is false if and only if there is some world and some V where VW of necessarily P is not the same as VW of P. Okay? So we can have a world that well, either makes this true and this false, or the first false and the second true. We should actually consider both of these possibilities. So suppose we have this world, say one of them here, W. Suppose this actually has this property. What must V be like in order for it to have this property? Well, suppose necessarily P is true. Well, then V of P is true, right? Because W is accessible from itself. So if necessarily P is true, then V of P is also true. So that can't be the assignment that we are looking for. Remember, we're trying to show that there is no such V, right? So assignments which make necessarily P true and P, so they can't provide the counterexample that we're looking for. Well, assignments that make necessarily P false, what would they be like? How can necessarily P be false in the first place? Well, only if either P is false, right? Then necessarily P is false. But such an assignment that makes P false here, again, makes this one false, so they are not different. So that's not the assignment we're looking for either. They have to be, its truth values have to be different. If this is false for this reason, then the other one is false for the same reason. That's not good. So necessarily P has to be false for some other reason. Perhaps P is true here, and this is the only possibility to make it false in any other way, right? P is true here, necessarily P is false there. Now we have necessarily P false and P true, but this contradicts our assumption that the frame is an identity frame. Okay, I mean this is a very fast way of going through the proof, but perhaps you can follow and see this, that we have ruled out this possibility. So this direction holds, because there can be no such, so the only way to produce a counterexample is to put in an additional link, but then it's not an identity frame anymore. And if we go in the other direction, suppose the axiom is valid, so this is valid, and F is not an identity frame. Now let's not consider the case where we are lacking loops, because we have already considered the reflexivity, right? That's one direction. Suppose it's not an identity frame because we have this loop, this arrow here. Then there has to be, and there will be an assignment of truth values to P that makes W a counterexample to this axiom. And of course, we just talked about one, right? So here, well, P true here and false here. Okay, now F is not an identity frame, but there is now a truth assignment, which is a counterexample to the axiom. I'm not sure if this helped. Not sure. Yeah. Okay, let's. Yeah, I can leave this up if you want to look at it some more. I can also go through it again, but it's perhaps not so important. So this is the axiom that goes with the total realism. Where was I? What did I want to say next? Oh, questions, right. So any other questions? We have about half an hour left. We can probably only cover one of these questions. Let's talk about the first one, about Ontic conditionals. Oh, I just said it was I fixed it. And this one as well. There is a problem, or perhaps we should call it just some kind of peculiarity with all of this regarding conditionals. If you think about the conditional, if alpha, then, and again we have this must here in parentheses, whatever, must alpha. That is certainly a conditional we can talk about. if alpha, then must alpha. Now, however you look at it, this, I mean, regardless of if whether you have ordering sources or whatever, this cannot possibly be false under the account. Okay, it cannot possibly be false, because even with these ordering sources, you're still evaluating. Remember, this is the same as, so okay, let's write it down here. V, W, F, G, all of this. You're still evaluating it like this: F plus alpha G, and then just must alpha, right? That's what we had. You are evaluating must alpha with respect to a modal base to which alpha has been added. Now, before we got rid of these annoying inferences by looking at some subset of this resulting modal base, this restricted modal base. Well, even if you look at the subset, you still have only worlds at which alpha is true. Adding alpha to F, yeah, ensures that. There's no way around it. Now, this is perhaps not so bad for sentences like if the material is heated to 500 degrees, it will be heated to 500 degrees. Although even there you might wonder in what sense that is then necessary, right? But you can make sense of it if you think about, epistemically at least, if I learn, or if I come to believe, if I find out that the material is heated to 500 degrees, then I will believe that the material is heated to 500 degrees. Okay, that makes sense. That sounds like it should be necessarily true, right? The problem is that you get the same necessary truth if you have deontic readings for the modal and the consequent. Because, like I said, that this is a necessary truth does not depend on any particular choice of F and G. I'm talking deontically. You get these examples that are here in on page 12. No, wait a minute. 16, for instance. If teenagers drink, then teenagers must drink. That comes out true. If they do drink, then they must drink. Right? Because at all the antecedent worlds, they drink. And if you rank them according to the laws, you still have only antecedent worlds at which they drink. Right? You don't get this idea that, well, they may actually drink, but in fact they shouldn't. That should make this conditional false, but it doesn't. And also, if they drink, then they may drink is true for the same reason. If I file my taxes, I want to file my taxes, and so on, all of these things. Here 17 as well, Britney Spears, at least at the time this paper was written, the one I'm referring to here, had a contract with Pepsi, under which she was not supposed to drink Coca-Cola in public. So 17a is true if Britney drinks cola in public. Oh, sorry, it's false. If she drinks cola in public, it must be Pepsi. That is false. But then under this analysis, the second one is necessarily true. If she drinks Coke in public, she must drink Coke. Right? So, I mean, 17a can be false. That's not a problem because Pepsi is a subset of the Pepsi worlds are a subset of the Coke worlds. But two conditionals are necessarily true. If she drinks cola in public, she must drink cola in public. And if she drinks Coca-Cola in public, she must drink Coca-Cola in public. Well, that's weird, right? Okay, do you see why that is? It doesn't make sense. Do you see that there's a problem here? These come out true no matter what you do under this account. So, without looking, at least for now, at these further problems that I have there, this has been discussed twice in literature. There is not much about this problem. It sort of goes away. It becomes less of a problem. In fact, it's pretty much resolved if you make one new assumption here about all of this. Namely that deontic modals in the consequent of a conditional are not treated in this way. Right? I said this equivalence, or the fact that these are necessarily true, is okay if you're talking about an epistemic must in here, epistemic necessity, because then it becomes something like if I learn P, then I will know P, something like that, right? That's fine. But not if I do P, then I have to do P. So for deontic modals, this approach is not quite right. And these authors have proposed that for epistemics, you might still want to do something like this, or at least something that is equivalent to this. But in general, for deontic modals, you want to do the following. And I will just write it. So they don't look like this in the first place. That's the idea. So if this is a deontic, if must is deontic, and suppose it is overt, it's not implicit, right? So have to or must is there. Right? If you have this, that this is not equivalent to this. With deontic modals, this equivalence gets us into trouble. With deontic modals, you want to do something else. So they don't look like this in the first place, but they look like this. If alpha, then now well, perhaps wait a minute. Let me start with. I'm sorry. Let me start with the lower line and then I'll write this one. Okay. So down here you want to say W F plus alpha G. This is in fact still the same. Okay. Must. But we are not talking about a deontic modal yet. Here, this is an epistemic or circumstantial modal base to which the antecedent is added. Okay. But then you don't ask, is alpha true at all of these worlds? You ask, is must alpha true at all of these worlds? So you go to these antecedent worlds where Brittany drinks Coke, and you don't ask, does she drink Coke at this world? Well, she does, right? The question is, does she have to do that? Is she required to do so? So the quantification, there is an epistemic modal involved in all of this, right? The conditional, actually, the antecedent restricts an epistemic modal base, and the deontic modal in the consequent does not take scope over the whole conditional. It is evaluated inside what would be called by linguists the nuclear scope of this quantification. That is, you're restricted to alpha, and then you assert something or you check something, right? The thing that comes in the consequent of the conditional. And what you check is not whether it's true, but whether it's required. So the modal is still there. It didn't go up. It doesn't play this role here. The deontic one doesn't. There is an epistemic one, hidden, a silent one, like in these other conditionals, where I don't have any modal at all, apparently, but still it's a modal expression. Well, the same thing here. You don't have this epistemic modal, still it is a modal expression, but you happen to have a deontic clause here, deontic modal in the consequent. Now this helps, this resolves the problem. Why? How does it do so? Well, let's see. So, so this is the epistemic modal base, the intersection of all of these. Okay. And alpha is somehow, it overlaps with these. Here are the alpha worlds. So it may be that Brittany drinks Coke. You don't know. And this may be, like I said, circumstantial or something like that. And now adding alpha takes you to this set of worlds, right? So this is once again the intersection of this thing, this epistemic one, right? Together with the notation of alpha, right? So far so good. We've seen this before. Okay. And now you ask for each of these worlds. And it doesn't matter whether you have an ordering source here, likelihood, something like that. At each of, suppose here you have a world V, and then you ask, is V such that she must drink Coke at V? Not does she drink Coke, but is the sentence she must drink Coke true at V? Right? Because this sort of goes together. So you evaluate this thing at all of the worlds in here. Now the modal is the modal sentence again. Now it may, it does certainly, it takes you to a modal base of its own, a deontic modal base, and some ordering sources. Well, I just said, well, I sort of, this is not actually, this is a problem. It may not be a deontic modal base, let's say a circumstantial modal base, but a deontic ordering source. That's the thing. So from here, you go to some other set of worlds, and it doesn't have to lie with an F, W or anything. So, somewhere here. Let's say it actually includes V. Let's say you have this. Let me even make it smaller. Okay. So this here is the intersection of all these things, deontic modal of V. Right? Oh, wait a second. Sorry. I just said it can be Sorry. Circumstantial modal at V. That's the modal base with respect to which she must drink Coke is evaluated. And then you also have